Hi, I'm P. Martin Ortiz. You may also know me as BeardScript. And in this video, I'm going to show you how I built a Flappy Bird clone with THREE.JS and Rogue Engine. Rogue Engine is a Unity-like environment for THREE.JS that I built, and you can download it for free at rogueengine.io. So we're starting with an empty project. The first thing we need to do is go into the marketplace on the top right corner of the editor, and there we'll look for physics, and we'll install the Rogue Rapier physics package. This is an integration of Rapier, a blazing faster Rust-based physics engine that we can use through WebAssembly. This integration will provide us with some components we can use in our objects to simulate physics. We won't be needing the skybox, so we'll head to the skybox tab and uncheck the enable checkbox. I'll be creating the assets with what we have at hand here, so I'm starting by scaling the default cube in our scene to about 100 on the x-axis and 10 on the z-axis to shape it into the grass side of the floor. We'll add a group and nest our cube inside. This will help us with picking objects in our scene, given that selection works in cascade and groups have priority over meshes. Inside the group, we'll create a second cube and scale it longer on the y-axis. This will be the lower side of the floor, so we'll go into the material and pick a light brown color. We'll need to move it down a further 0.5 so it doesn't overlap with the grass. Pick a greenish color for the grass and then name the group to make it easy to recognize it in the hierarchy. Now we'll press A to open the component menu, we'll add a rapier body to the floor group and set the type to fixed. Then we select the grass mesh and add a rapier cuboid shape. This represents a physical shape that we can collide with. We'll add a plane mesh for the sky and scale it wide and tall behind our floor, then pick a sky blue color for its material. We won't be needing the sunlight or ambient lights, so we'll get rid of them and add a hemisphere light instead. I like keeping the lights higher up in the hierarchy, so I'll drag it to the top. Move it around until you're happy with the angle. Now I'm making a group for the bird, and for the sake of this video, I'm just putting together some primitive meshes. But you could import a nice 3D model, of course. Same goes for the floor. One important bit I'm doing here is creating a folder called Materials, open it, and save the bird's body material by hitting Save Material Asset. Now we can share this material with the wings simply by dropping it in their respective material fields. Now I'll just keep adding bits here and there until I'm happy with it. Now we'll head to the Assets folder, create a new folder called Prefabs, and then we'll drag the bird group and drop it in there. Now we can safely delete the bird from the scene and drop it back in any time. Now before we lose anything, create a folder called Scenes and hit Ctrl S to save the current scene. I'll call it Main. Now I'm putting together the pipe using a lathe and a very long cylinder. You can copy these points for the lathe if you want. Or better yet, bring in an external asset, just make sure the pipe is long. Select the pipe group and drop it in the prefabs folder. Now we can safely get rid of it. I'll create another group, call it pipe pair, and drop the pipe prefab in it twice. We'll pick the bottom one, set the position Y at -4, then pick another one, rotate it 180 degrees on the Z-axis and set the position Y at 4. Now select the pipe pair group and drop it in the prefabs folder. This will create a prefab with nested prefabs. So now when we modify the pipe prefab, it'll reflect in the pipe pair. Now we'll add back the bird prefab, and inside of it, we'll add an object 3D and call it Collider. In it, we'll add a rapier ball component. But we can't see the collider yet because it gets added to the nearest parent with a rigid body and we don't have one yet, so select the bird group and add a rapier body. Now we can see the collider. Drag and drop the object on top of the prefab file again to save it. In order for physics to work, we need to initialize them. Let's add another group, drag it to the top and call it Game Logic. Select it and add a rapier config component to it. This will initialize Rapier for us. So now if we hit play, you'll see how the bird falls to the floor. We only really care about physical reactions to forces and collisions on the y-axis, so we'll go to the bird's rapier body and leave only the y translations enabled. I also want it to fall faster, so I'll set the gravity scale on the rapier body to 8. Don't forget to drop the object on top of the prefab file to save it. Now back in the Assets folder, we'll create a new folder and call it Components. We'll open it and create a component called Bird Controller. Wait for the compiler to finish, it should only take a couple of seconds. And now we can select the bird and drop it in the inspector. Now open your project folder in your code editor of choice, in my case VS Code. This will make it much easier to navigate your project files. Now let's find the bird controller we just created. I'll be using TypeScript, but as always, it'll look almost exactly the same as a JS component, so you can easily follow along with that. Just omit the types. That said, I do highly recommend using TypeScript. We'll start by getting rid of the awake and start methods and add a jump speed field with the numeric decorator. The decorator is just there to tell the engine that we want to see a numeric field for that property in the inspector. Now we'll import the THREE.JS library in this way, then add a private field called jumpForceVector and make it a new vector3. Now we'll import the rapier body component. You can use @RE as a shortcut to the rogue packages folder. Then I'll add a private _rapier body. And we'll use a getAccessor to get the rapier body component in this.object3d if our field is not defined. Otherwise, we'll just return it. Then in the update method, we'll set the y-axis of our jump force vector to our jump force value, and we'll define a jump action. This basically says that if we hit space or left mouse button or we touch the screen at all, we want jump action to be true. Now, one thing I like to do is define a v0 variable before the class definition so that we can reuse it on every frame instead of needlessly creating new objects that will trigger the garbage collector. Then we'll say that if our jump action is true, we want to set the linear velocity of the body in our rapier body component to 0 and then apply an impulse towards the jump force vector. This will reset the forces and prevent them from adding up. You can greatly increase difficulty just by omitting line 29. Those true parameters will tell Rapier to wake up the bodies if they are asleep. The body property is just Rapier's rigid body. You should check out Rapier's docs to learn about available methods and properties. Now back to the editor, if we hit play, you'll see that we can't jump very high. Play around with the jump force until it feels right for you. I'll leave it at 140. Don't forget to save your prefab. Now let's create a new component and call it GameLogic and drop it in the GameLogic object. Don't forget to save your scene. Let's open a new component in VS Code. We'll get rid of the awake method and add a prefab decorator to a field called pipePair. Then we'll add a numeric list decorator to a pipe heights property. This will be an array of heights to place our pipe pairs. Then we'll add fields for the pipe distance to define the gap between pipes, the pipe's count to define how many pipes we want at one time, and the pipe speed to define how fast pipes should move. Yes, we're going to move the pipes, not the bird. This is a common practice in all game engines to prevent us from breaching the floating point limits of the world. I recommend reading up on the subject if you're interested in procedural worlds. Now we'll import THREE.JS like before, and then below the update, we'll add a method called addPipes and another one called addPipe, where we'll pass a pipe object and x and y coordinates. We'll also need another method called getRandomHeight to pick a random height from the pipe's height array. Another thing we'll need is an array field to hold the instantiated pipes. We'll call it curvePipes and initialize it in place. We'll start with the getRandomHeight now. Here we'll use JavaScript's math library to get a random float from 0 to 1. We'll multiply it by the length of our heights array and use the math.floor to round it down to an integer. We then return the height at that index or 0 if the array is empty. The addPipe method will add a given pipe to the curvePipes array after setting its position to a given x and y with the set at -1.5 to keep the bird in front. It's just a visual trick. From our angle, it'll look like they are on the same line. The addPipes method will instantiate the pipe prefab as many times as we set the pipe's count to, and we'll call the addPipe for each of those instances, maintaining the pipe distance gap on x with a head start of 20 and a random height for the y parameter. Now we'll call addPipes in the start method, which is executed when we start the game. Back to the editor, you can see how our GameLogic component is showing our property controls in the inspector. Now we can go to the prefabs folder to drag and drop the pipes pair in the prefab field. I'll add 3 elements to the pipe heights array and I'll set them at 5, 10 and 15. You'll want to play with these numbers until they feel right. If we hit play now, you'll see the pipes showing up in our scene. I'll move the camera a bit and set the pipe distance to 10. Now we need to make the pipes move, so back in the GameLogic component, we'll add a private field called pipeMovement and make it a new vector3. Then we'll add a movePipes method where we'll set the x-axis of the pipe movement to minus the speed times the delta time. This is the time that has passed since the last frame. This way our movement stays consistent regardless of the frame rate. Then we'll iterate the curvePipes array and add our pipe movement vector to the pipe's positions. Then we'll head to the update and call our movePipes method. Now back to the editor, when we hit play, it looks like the bird is moving. This might be a good time to adjust the camera positions and the GameLogic values. I'll set the heights at 8, 13 and 18. I think this looks right, but you can do whatever you want. I'm also bringing back the pipe prefab to adjust the gap. I'll make the Y positions 5 and -5 and drag and drop to save the prefab. I would also like the bird to fall faster, so I'll set the gravity scale of its rapier body to 9. Again, it all comes down to personal taste. Now, we have a fixed set of pipes, but we actually need an endless supply of them. So back in our game logic component, we'll add a method called createEndlessPipes, how original, eh? And in it, we'll say that if the position in X of the first pipe in our list is smaller or equal to the total distance covered by half of our pipes, we'll remove it from the array and add it again at the back position after the last pipe with a new random height. This is a much more memory efficient alternative to creating endless instances. It will help us prevent needless operations and triggering the garbage collector by reusing our instances. Then we'll head to the update and call our new method. Now when we hit play, it looks like we are in Mario's worst nightmare. Back in the game logic component, we'll add a new field above the pipe pair to hold the bird prefab. Then make sure you save the prefab and drop the file in our newly created field. Now for the UI, we'll keep it super simple. Let's head to the components folder and create a new component called UI component. I'll open it VS Code and add a text prop control called URL and another field called container that will initialize as an HTML div. We'll only need the awake handler and we'll need to make it async so that we can await the synchronous calls inside. First, we'll set the container's display style to none to hide it. Then we'll use row's getStaticPath method to get the given URL relative to the address of the static folder. This makes sure it works both in the editor and in exported projects. Then we'll get the contents of the file on that URL and set it as the inner HTML of our container. Finally, we'll append our component's hidden container to the runtime's built-in UI container. Now we need a method to show the container. We'll allow some arbitrary arguments that will come in handy later, and then another one to hide the container. Now I'll go to the static folder, the root of our project, and add a styles.html file. Here we'll add some common CSS inside the style tag. I'll start by importing a font I found on Google Fonts called Luckiest Guy. Then I'm adding some styles to the built-in runtime container using the rogue UI ID. Think of this as the body tag of our game. Then I'm defining a main text class with the imported font and an outline. And finally, I'm adding a button class. Feel free to copy this, but it really comes down to personal taste. I'll add another file called startmenu.html. This will be a simple header with our game title and a message to tap or press space to start the game. I'm also adding some additional styles that are specific to this component, including a simple grow and shrink animation for the message. Now back at the editor, we'll add a UI component below the game logic component and set the URL field to styles.html. We'll add another one and set the URL to startmenu.html. And we'll set a name for these components. We'll call them UI styles and UI start menu respectively. Now back in the game logic component, we'll import the UI component. We'll add the styles and start menu properties to hold the component instances, and we'll also need a game started flag set to false by default. In the update handler, we'll place the contents inside an if game started condition, and in the start menu, we'll replace the add pipes call to get the UI styles and the UI start menu components by the names we gave them. You'll need to cast them as a UI component if you're using TypeScript. Finally, we'll call their show method. Now we can press play and see our UI in all its glory. Now back in our code, allow the startGame method right below the update, and in it, we'll start by adding the start menu, setting our game started flag to true and instantiating a bird prefab. I'll set its Y position to 5 for now. And finally, we can call the add pipes again. Now in the update, we'll say that if the game hasn't started, we'll check for the start input and call start game. Now we can hit play and press space to start the game. But we don't really have a game yet, so back in the static folder, we'll add an ingame.html file. I'll make it a simple h1 tag with an ID of in-game score and some styles. We need yet another file called gameover.html, and here we'll add a few headers for the titles, and then a div with an ID of gameoverscore to show the current score, and another div with the ID of gameoverbest to show the high score. Finally, we have a button to try again with an ID of gameoverrestartbtn. We'll need all those IDs later. I'm also adding some additional styles here. Now back in the editor, we'll create a component called UI ingame and another one called UI gameover. I'm prefixing them with UI to keep them together. And then we'll add them both to our GameLogic object. I'll start with the UI ingame. This will extend our UI component, so we have to import it. We'll get rid of everything and add a score div property. Then we'll add a show method where we'll call the show in the parent class and then get the score div using the ID we gave it in our HTML. Finally, we'll need a setScore method where we'll pass a number and set it as the inner HTML of the score div. UI GameOver will also extend from UI component, but here we'll only need a show method where we'll pass the score, the best score, and the handler function to restart the game when we press the button. We'll call the show method in the parent class like before and get the score div, best div, and restart buttons using the IDs we gave them in the HTML. We're also setting the inner HTML of the scores and the onPointerUp event handler of the button to the restart function we are passing. Now we can go back to the editor and fill up the URL properties for our new components in the inspector. Back in the GameLogic component, we'll import UI GameOver and UI InGame. We'll create fields for them below the styles and start menu. And in this case, we can use Rogue's getComponent since we can pass in the class, so if you're using TypeScript, you won't need to cast them. Now in the start game method, we'll show the in-game UI and set the score to 0. But we need a few more things here, so I'll go ahead and add a GameOver flag, a couple of fields to hold the score and best score, and another one to hold the bird controller, which we'll need to import. Now under the start game, I'm adding an onRestartArrow function so that it will hold the scope of this when we call it from the button's event handler. In here, we'll simply remove the bird instance using the reference in the bird controller, and we'll iterate the pipes array to remove them before reinitializing the array. Then we'll hide the GameOver UI and show the start menu again before setting both the GameOver and GameStarter flags to false. Now back in the start game method, we'll need to set the score property to 0 and get the bird controller component in our bird instance. We'll use its RAPIER body property. This is the getter accessor we defined earlier, remember? We'll set its onCollision start handler. This method provides an info parameter with useful information about the collision. We'll say that if we hit a RAPIER body component in an object named point, we'll add 1 to the score and set the new value in the UI. Else, we'll say that the game is over, disable the bird controller, and hide the in-game UI. If our score is greater than our best score, we'll set a new record. And finally, we'll show the GameOver UI passing the scores and the restart handler. Now in the update, we'll say that even if the game has started, we want to move the pipes and replace them only if GameOver is false. And in order for this to work, we need to bring back the bird prefab, select the collider, and tell RAPIER that we want to receive collision events for it by checking the collision events box. Save the prefab and delete it. Lastly, we need to bring the pipe pair back, and inside we'll add an object 3D and name it point. We'll give it a RAPIER body and a RAPIER cuboid. Make the body type fixed and set the cuboid to be a sensor so that it can't physically react to collisions. We'll set the collider's Y and Z scale offsets to about 10 and move the object slightly to the right so that we count the point once we cross the gap. Drop the object on the prefab file to save it and delete it. Now if we hit play, you'll be able to score points and we'll die when we hit the floor. And if we hit the try again button, it takes us back to the start menu. I'm gonna start the bird a bit higher by setting the Y position to 15. Yeah, that feels about right. Now we need a collider for the pipes, so let's bring the pipe prefab back into the scene and add a RAPIER body to it and make its type fixed since we're not using forces to move it. Now you know the drill, add an object 3D, call it collider, and let's add a RAPIER cylinder this time. We'll make its half height 25, and in my case, the Y position fits about right at 24.3. I'll save that prefab and remove it. Now when we hit the pipes, we die. I don't like that it gets stuck to the pipes though, so we'll add it back and make the collider a sensor. See, now it looks like we're falling right beside them. Our game is basically done, so now I'm just going to stretch the sky a lot wider so that it's always visible and pull it back a bit. Then I'll add some icosahedron geometries and shape them as something that resembles mountains. Move, rotate them, scale them, duplicate them, all that. I'm also going to set the camera field of view to 20 and push it back to about 70 on the Z axis. This makes it look so much more cohesive. Now if you scale down the window, you'll see that it simply crops down the view. So to make sure it looks its best in most screen sizes, I'm going to show you a little trick. Head back to the GameLogic component and add a curve width and curve height private field set to 0. Now right at the bottom, I'll add an adjust camera method. In there, we'll say that if the height or width of our screen have changed, we're going to set the new current values and get the aspect ratio. Then we'll say that if the aspect is smaller than 1, we'll increase the zoom of the camera to 1.1 times the aspect ratio, and if it's greater or equal to 1, we'll decrease it to 0.4 times the aspect ratio. You can adjust these numbers to the needs of your particular app. Now, since we've made adjustments to the camera, we need to update the projection matrix. Finally, we'll call it first thing in the update. Now adjust the camera position to your liking and test on different devices using the address on the top right to see the results. Now to export your project, go to Rogue Engine on the top menu, select Build, and then drop your scene files in the Build menu, in this case just main. Hit Build for Web, and there it is. Go to the Build folder in your project files, and you'll find the web files which you can host on any static server. If you have a Rogue Engine license, you can go to the Rogue Engine top menu, select Publish, and create New. Fill up the form and submit. In a few seconds you'll find your build in the list with a link to play it on the web. And there you go, we have a complete Flappy Bird clone. I challenge you to use this as a template to create your own version, and don't forget to share it with everyone. And tag me on X and I'll like and repost it. Well, that's it for now. Thanks for sticking to the very end. Ciao ciao.